Greetings and welcome to Maya 101, week number 3, where we take a look at the process of surfacing, also known as texturing, if you want to call it that. Basically, we're going to take all of those flat, plain, boring, gray objects that we made in the last class and make them significantly more interesting by adding some materials to them. Now, this process is pretty easy. At the end of the day. I mean, the concepts to it are very, very simple. However, materials are a huge topic that you could just go on and on and on about, and you could really spend, I could probably take months just showing various things about creating materials, especially if you branch that off into taking a look at all the mental ray materials and stuff like that. Now, for tonight's class, we're going to be keeping things relatively simple. My goal here is just to get you to the point where all of the objects we've created so far have some type of material on them. Now, later on, provided we have some time, and hopefully we will, I will be showing how to create a very simple material if any of you created an extra object for your scenes. Actually, in the other class, in the Thursday class, there was a little bit more time at the end of the session. I mean, sometimes things just go faster in one class than they do on another, you know, it happens. And so I was actually able to really quickly knock out the modeling of a teacup. So if you want to see how to model like a really basic teacup, you could go on over to the videos for that class, watch the second half, fast forward a little bit, and there's a nice walkthrough if you just want to, you know, have somebody show you how to make something. So with that out of the way, let's talk a bit about materials in Maya. What is a material, first off? Well, a material is really just a definition for a surface. Meaning it's going to answer various questions like, what color is that surface? What sort of shininess does it have? I'll use the really basic term for now. AKA specularity. Is it bumpy in any way? It answers a whole lot more than this, too. I mean, it really just goes on and on with all kinds of other stuff. But really, if you had to sum it all up in a single statement, a material defines how light interacts with the surface. That's really the main job of a material, is to define how light is going to interact. How is it going to reflect off? In what direction is it going to reflect off? Will it pick up some color as it reflects off and heads back to your eyes or the camera because it's a 3D scene? That's the whole idea. Now, several of you have probably heard the term texturing. Who in BuzzNet has heard the term texturing? Okay, a few people. That's good. Most folks. Now, is there anybody out here who does not, I want to repeat, who does not know the difference between texturing or textures and materials? Who does not know the difference between textures and materials? Okay, that's cool. Well, I can make this relatively simple for you. Let's pretend that I have the best drawing skills in the world, and that this is some sort of object in Maya. So this is going to be like our little cherry. So, and obviously my hand is shaking a little bit from all the coffee I've been drinking. A material is actually what gets applied to the surface. Actually, let me try this a slightly different way and make my eraser smaller, because that's just a monster eraser. I don't need that much. I need sound effects too. Cool. So material, which again, a material is just a definition for how light is going to interact with the surface, is applied to that surface. Textures, on the other hand, are actually parts of the material. So a texture will plug into a material and define or help define some aspect of that material. The material itself is what actually gets applied. Ryan, I'm not sure how much you missed. Just watch the first, well, right now we're at 5 minutes on the video, so you haven't missed too much. Just watch the first 5 minutes of the video when it goes up, and you'll see everything that you missed. And probably then some. Alright, so that's what a texture is. Now, the really short and easy definition, in fact, before I even get to texturing, let's just go with texture as a thing. Or texture is plural. They're really just images. That's it. They're pictures, literally. They can be in JPEG format, like the kind of thing you download off the internet. They can be in PNGs. They can be anything, and they got a whole bunch of other formats, too, that you generally don't see outside the scope of 3D animation. But they are just a flat, two-dimensional image that in some way gets wrapped around a 3D surface and is applied to a material. So always remember this. Textures go into materials, materials go onto a surface. That's the big thing you need to walk away from this with. Now that's true in Maya, that's true in 3ds Max, it's even true like in UDK and true in Unity. Everywhere you go, you're going to apply a material and then the textures plug into the material. Now the process of texturing, which we're actually not really going to do tonight. I'm not going to crack open Photoshop and produce a whole bunch of custom textures, mostly because we don't need it for this type of project. But the process of texturing, just so you know what it is the creation of two things, really. The image itself, so texturing is creation of texture images. And often, it's also the creation of UV coordinates. So this brings us to a whole different topic. UV coordinates. Now, I'm not even going to ask. I'm just going to assume that you have no idea what UV coordinates are. UV coordinates, yeah, Ben CG says UV coordinates are equals my nightmare, that sort of thing. There's nothing to them. They're very, very easy. You just, now Ryan said, he said they're lighting coordinates. Hey, Ryan, if you're just going to say random stuff, would you please say that inside a BuzzNet and save the question system for when you have an official question that you really, really need me to address in the video? Now, which part of a material is not a texture? Mostly settings that are inherent to the material itself, or any, in the case of Maya, any other nodes that are not texture-based, such as utility nodes, and a variety of other types of nodes that you may plug in just to handle some other aspect, usually in some way to manipulate a texture and plug it back in, but not always. So, let's talk briefly about UV coordinates. I'll give you a heads up, just for tonight, for this class, we're going to leave the concept of UVs really, really basic. We're just going to create some really generic ones for our cake. And let's see, we don't need any for our cherry, necessarily. If you guys have a separate object, we may create some really simplistic UVs for those, but we'll get to that a little bit later tonight. For now, I want you to know just what UVs are. So let me draw a diagram of a super complex 3D object. There you go. There's our super mega ultra complex 3D object. It took us weeks to get that modeled out just right. So, up to this point, you guys have already seen the concept of a vertex. Vertices are points that you move around in 3D space to define some type of shape for a polygon object. Well, what if I told you that this vertex, of course, we all know that it has coordinates in 3D space. It's got a coordinate for x, which could be any number. We're not going to worry about the number. It's got a coordinate for y, and it's got a coordinate for z. Now, all of these, as I very carefully remove that superfluous colon there, all of these are 3D space coordinates. That's how we know where that vertex is located in the world. What if I told you that this vertex also has an entirely separate set of coordinates that exist kind of in another dimension, really, not to blow your mind or anything, but we also have U and V. These are 2D space coordinates. Every single vertex has got these, or at least should. You can break it so that they're not there depending on which modeling tools you're using, but before you see textures on it, you had to have these UV coordinates. Now, here's the thing. This is what throws a lot of people off. Yeah, and if your mind feels like it's blown, if it feels like it's a whole bunch of string theory stuff, fear not. It's really not that bad. All objects inside of Maya, or in a lot more than just Maya, actually exist in two different manners in terms of these coordinate systems. You have the one 3D coordinate system, which gives you a three-dimensional shape. You can rotate around it. Because 3D space looks a lot like this. So in the case of Maya, we have Y, we have X, and we have Z. It goes off in 3 different directions. 2D space is exactly what you would think it is. It is just a 2-dimensional grid. Now, you may already know this, and if you know this, that's fine, but can anybody fancy a guess? Just give me some sort of, imagine why on earth you would need all of your 3D models to have coordinates in 3D space and a separate set of coordinates for 2D space. You want to just like throw a rock at it and see if you hit it? Raven's kind of on the right track. He says for texturing each face. That's exactly right. But there's a little bit more to it than that, because if you were to take a 3-dimensional object, say this box, and you wanted to literally print something on it, I don't mean load it into Photoshop, because there's probably 1 or 2 smartasses in the room who'd probably be quick to remind me, hey, in Photoshop CS, you now have 3D objects and things like that. But if you literally wanted to take a 3D object and put it in your inkjet printer and print some sort of picture right onto the surface and then fold it all back together, you couldn't do it. Not without actually ripping your entire model to pieces, unless you had a separate coordinate system literally just for 2D space. And that's the whole reason we have these. It's just a way that you can have one set of vertices that make this look like a box, and another set of vertices that make it look like a completely flattened box, as I try my very best to draw a completely flattened box for you. Well, one way to do it anyway. There's a lot of different ways to draw a flat box. Here's a common way. The old-fashioned cross style. Because if you were to take this and fold all of these little creases in a downward direction, you would end up with a 6-sided box. That's the whole idea. This is flat. Flat is good. Why is flat good? Because flat can be opened up in Photoshop, and I can paint a smiley face right in the middle of it, and I can draw, I don't know, whatever I want. I could draw a picture of the world here, and I could draw the letter Z on this face, and then I can send this flattened information back into Maya, and because we have these 2-dimensional coordinates, that texture then gets applied in 3D space, and we end up with, I guess, what would be like a smiley up here, and we end up with the world over here, and, I mean, I guess it would be like a letter Z that would be down here on the bottom. So, that's how this works, and that's why you need these. You need some way to flatten out a model in such a way where it can be read in by some sort of image editing software for the purpose of creating your textures, but you have to do it in such a way that doesn't tear apart your model. It still needs to retain its original 3D shape. The only way to get around that is to have 2 separate coordinate systems, one for 3D space and one for 2D space. Now, is there anybody here who's still completely lost? Okay, so folks are kind of getting, if you still feel a little bit confused, Don't worry, because you're going to get to see this in a limited fashion. Now again, just as a reminder, tonight, my goal is not to get into the process of texturing. I am not going to open up Photoshop, bring in a UV layout, and paint stuff on top of it. I'll save that for later on down the road. We do like a texturing class or something like that. For tonight, we're going to keep things very, very simple. Are UVs related to normals at all? Yeah, that should have been in the official question system. The answer is no, not really. I mean, they're all aspects of vertices. Vertices have normals. They also have UV coordinates, but they don't relate in any way. You can, if you want to make UVs in your head, you could just internally make these synonymous with the term texture coordinates. Because it's just a second set of vertices, literally, that only exist in 2D space, just to make it easier for you to texture something. Now, I'm going to throw this out, and it's going to make sense to some of you, or it won't right now. And if it doesn't, don't stress. Just remember I said it for later on down the road, okay? And actually, if you want to learn a lot more about this process, I highly recommend you take a gander, take a glance, take a look, whatever, at the Maya ADP videos, because we do a whole lot of texturing and stuff over there. But in any event, I imagine most of you have, at some point in your life, looked at a world map. World maps actually are a really good way to explain UVs and some of the pitfalls that you can run into. Because, and I mean, I guess I could Google, let me see if I can Google some pictures real quick to show, rather than have to draw everything out. Let's see, that's pretty good. You want like the old school ones that isn't like a cleaned up version. Here we go, an old-fashioned map. Perfect. So here's an old-fashioned world map. And I realize it's pretty small, but you don't really need to see too much of it. But here's one problem with UVs. What is the purpose of a world map? Can anybody like really quickly sum up why we made a world map? What was Columbus's job? I mean, he wasn't just trying to discover the new world. Now somebody said, where are normals again? There's actually some different kinds of normals. There are vertex normals and there are face normals. Face normals control which side of a polygon is facing outward. Vertex normals help control shading across a surface, and they're how you get things like rigid creases from one vertex to another. And we'll talk about that here in just a moment. Let me get back over here to my map of stuff and bring up BuzzNet. Yeah, actually, it's a good way to see the world, and somebody already said that. It's a way to take this. So, here's the Earth. Shilling, damn, that's a pretty sweet Earth, you might say. And convert it to a flat surface. Now, the problem with doing that is that a round object doesn't really translate very well to a flat surface. Has anybody ever tried to take like an orange peel and flatten it out on a table? Next time you're bored, try that. See if you can take an orange peel, and without tearing it, I mean, because it's going to be a little torn anyway, so take the whole thing and try to make it a perfectly flat square. It won't happen. It's going to get tearing in it. And this is where you end up with the concept, and again, if this doesn't make sense or if it confuses you, just remember I said it for later on in your life. You get the concept of seams versus distortion. So when they were making the first world map, they had a lot of distortion. How can I prove it? Look at Greenland. It's bigger than most of North America. I mean, like the entire United States could fit inside this. And that's just ridiculous. The reason is that all of this, everything you see up here, is all getting gradually smaller. Look at these lines of longitude that are just snaking up to the top. You see how they're all nice and parallel? What should all of these points be doing right up here along the top? Anybody tell me? Curving. That's one way to look at it. Curving is right. Unless you look at them edge on. Then they're not really curving. Meeting together. Wick gets the cookie. All of these points, every single one of these dots is a single location. So while on the map it looks like, oh, I just traveled all the way around the world, you can actually touch all of these points by standing in one single spot. So the result is that the map was actually stretched when all of those were pulled apart. And this map, they actually got wise. They went ahead and took off Antarctica, because on this version of the world map, Antarctica is just ginormous. So that's the concept of distortion. In order to take something that was three-dimensional and stretch it out flat, there has to be some sort of distortion to make that happen, because 3D objects don't like to become two-dimensional. Your only other option is to try this. And some of you might have actually seen this before. Let me see if I can open up a good rendition of it. This is not too bad. Probably one or two of you have seen a world map that looks something like this. This is the same thing, but what they've done is they've actually created seams in the image so that they could retain nice proportion in the areas that matter. In this case, they don't really care that there's a seam in the ocean, and that if you go right off this part of the map, you magically teleport to this part of the map as you continue moving forward. What they wanted was what looks like North America, South America, Africa. It doesn't look like they cared too much about Asia, to be honest. They wanted all of these to retain as much of their size and actual shape as they possibly could. So they created these seams to help eliminate as much of that stretching as possible. So when you take a three-dimensional object and you try to lay it out flat, you'll end up with one or both of these, and it's just your question of which one you want more of. You will end up with seams, and you'll probably have distortion. And if you have less of one, you will have more of the other. In this case, you could make a layout like this for a cube that had no distortion whatsoever, that nothing was actually stretched in any way, because each single square of this could be exactly proportional to a single polygon in 3D space. That means you get no distortion. Fantastic. But all along here, all along the outside, these are seams. You'd have to find some clever way to deal with those. So that's a really quick rundown of the concept of seams versus distortion. I just wanted to throw that out there strictly for your benefit. If you're completely lost or it doesn't make sense to you, again, please do not be too concerned. That's something that will come to you later on. I just want you to realize that if later on you start playing with UV coordinates, you're like, hey, I'm getting all of these funny gaps, or my texture, which maybe you type something. You know, you type like a warning label and you want to put it on the side of a can, and it looks like it's all skewed and doesn't look right. I just want you to kind of know why. Okay, now with all that out of the way, let's move on to my next topic. I know, we are going to get to Maya tonight, I promise. Materials in Maya. Materials in Maya are really, like everything in Maya, but these are particularly heavy in this area. They're just nodes. Every material you make will be a single node. You'll set some properties on it, and you'll plug other nodes into it to create a network which defines your material. The purpose of these nodes, which are put into networks, which you'll see later tonight, it's really just a way for you to define... pretend this is either a sheet of computer printout or a screen. It's just a whole bunch of programming code. Also known as shader code. Now I just threw a whole nother word in there. Shader. What is a shader? A shader is an algorithm. It defines light interaction. Now wait a minute, doesn't that sound like the exact same thing as a material? Well, it kind of is. A shader is often going to be a specific style of calculation that handles light in a very, very particular manner. With all of that vaguely understood, let's jump into Maya for just a minute. So everybody open up Maya. I want you to go to Window, Rendering Editors, and open up the mighty, mighty Hypershade. Now, your Hypershade probably looks something like this. Probably. If it doesn't, you can click on this little button for show top and bottom tabs. But you have a lot of different materials you can create in here. You have a Lambert material. Now, I'm just middle mouse dragging these into place. You do not have to do this, by the way. I'm just doing it to show you some stuff. We have a Fong. We have a Fong E. We have Surface Shader. We have one of my favorites, which is a Blinn. We have an anisotropic. And all of these are different shader algorithms that each have a different mathematical definition for how light should play off of a surface. So they're the same in that they all do the same job. They all allow us to create specific material networks in some form or fashion, but they're using different shader systems to figure out how that light's going to work. An anisotropic would be good for like brushed metal or the underside of a CD. A Blinn is generally good for metallics. It's just a little heavy on the machine. You can make a Fong look pretty much like a Blinn, but it's just a different calculation. Some other mathematician came up with an entirely different series of mathematical functions to define how light should be playing off the surface. In fact, that's what most of these are named after. Fong, Blinn, and Lambert were all three mathematicians who wrote out the equations for how light should be working. So very, very smart dudes. So that's just a quick rundown of the difference between a shader and a material. Again, I'm trying to keep things relatively basic. All right, now, with all of that done, we've already burned about 25 minutes just talking about all kinds of stuff. Whose head hurts? Tell me in BuzzNet. Does your head hurt yet? Is the anisotropic also used for point lights? No! These are surface shaders. These are materials that are applied to a surface, not to a light. A light can have shaders if you want to get really, really technical, but we're not going to dig into that right now. We're going to keep things very simple and think about lights as if they were just real light-emitting things in the real world. Okay, so with all of this down, I guess it's time for us to go ahead and start creating some materials for our objects in our scene. So if everybody would be so kind, go ahead and open up the scenes that we left off on at the end of the last class. And while you're doing that, I'm going to do something real quick. In fact, I'm going to pause the video while I do it. I'm going to bring in the object that I modeled at the end of the Thursday class. Okay, we are back, and I've imported in the cup that I made in the Thursday class. So if you want to see how to make this, you can jump over to the videos for the Thursday class. And it's just a really, really basic cup that we took a chip out of, just, you know, for the fun of it. What was I going to say? I actually had something. Somebody asked earlier about vertex normals, or at least I feel like they did. Do you see all these hard edges that are defined here? These are actually created by vertex normals. I said there was a difference between vertex normals and face normals. Face normals define which side of a polygon you're looking at, the positive side or the negative side, the front or the back, if you will. Vertex normals actually help define smoothing across a surface. So you see how this side of the cup feels kind of smooth here in the middle, even though you can see the edges all the way around? That's because all of those vertex normals are nice and unified. Where they separate, though, you get these hard edges. It's not like the shape of the surface has changed in any way. It's still just as faceted either way, whether it's smooth or not. This is just a rendering trick to help the viewport and the rendering engine define whether or not you should be looking at each individual facet, at various seams between those facets, or if you just want to see a smooth result. And just, you know, for shiggles, you can right-click, or shift-right-click, and go to Soften, Harden, Edge, and say Harden Edge, and that will just facet everything, like so. You can do the same thing and just go to Soften Edge, and that will soften everything. You just have to watch out, because wherever two surfaces meet at a really, really stark angle, if you have a soft edge in between them, then you end up with these rendering glitches. To fix those, you could go edge by edge. I'm going to turn off soft selection. You could grab these individually and shift right mouse and just harden those up alone, and it helps solve the problem, because you see we're starting to get a crease right there. Anyway, that's, you know, additional, just kind of for your benefit, random stuff. So, let's see, there were a few questions that came in. Zach, can materials in Maya be rendered out to be used in something like Unity UDK? Well, because Maya is exporting FBX to go into both of those applications, you do get something very similar to your material that should go along for the ride, but not all of the features of Maya's node system are going to be compatible with those game engines. So the short answer is yes. The long answer is you have to be really careful how you do it and keep your material relatively simple, because there's a lot of stuff you can do with Maya's nodes to make a material really, really complex, and it won't translate very well. So yes and no, or it depends, which are two of my most hated answers to just about any question. Okay, so here we are. We need to start creating some materials. So the way I like to do this is as follows. I'm going to do most of my work tonight in the Hypershade. There are a couple of reasons for this. The biggest one is that I realized that Maya 2013 is pretty new, and that not every single one of you is going to be able to lay hands on it. There's probably one or two of you out there that are still using Maya 2012. The Hypershade is kind of like the lowest common denominator of material construction systems. The node editor is Maya 2013 only. We will be taking a look at the node editor, but we're going to do most of our work in the Hypershade just out of fairness. What Zach just talked about, is that baking a texture? It can be, but not always. I mean, baking a texture would be a good way to do it, but if you're doing something really, really fancy in a material, like using a Fresnel calculation so that your color changes when you look at an object from different angles, like the paint job on like a really cool lowrider sports car or something, then you're probably going to have to rebuild a similar network over inside of UDK or Unity to make that happen, because that can't bake. It's constantly changing depending on the incident angle of the camera. All right, now back over here. When I am creating materials, I will generally split my screen up, and here's how I'm going to do that. Let's go under Panels in my viewport and go to Layouts, and I'll do 2 panes stacked, like so. No, I don't mind Wick. I just wanted to throw it out there. I saw the question. I was like, hey, I could answer that. So let's go over to Panels on this lower viewport, and we'll go under Panel and choose Hypershade. And there we go. So now we have a Hypershade and we have a viewport. We have our attribute editor. The attribute editor is of massive importance when creating materials. But I am going to try to buy a little bit of real estate space back, so I'm going to right-click and hide out my toolbox. You'll also notice I have my time slider, my range slider hidden away. I don't even really need my help line, so I'm going to go ahead and turn that off as well. Let's see, what else can I use to save myself a little bit of time and hassle? I probably won't need my status line very much, so I can turn that off, and that just gives me a little more room to kind of see what's going on. Remember, at any point, you can bring these back. You can just go under Display, UI Elements, and turn those back on any old time you need to. Okay, so with that, let's start with the plate. It's going to be probably by far our simplest material, because if we wanted to, we could just make this a simple, basic, flat material. We don't really have to do anything with it if we don't want to. So what I'm going to do is grab a Phong material, and I don't really need to see the upper area right now. So the top tabs, I'm going to turn those off, and I'm going to do that by clicking on Show Bottom Tabs Only. It just gives me a nice big work area. I also will not be using this list on the left-hand side here in my Hypershade. So you see there's a splitter bar here in the middle. If I click and drag that to the left, that just slams everything over, and now all I have is this one nice big list. So again, just trying to utilize my real estate space as efficiently as I can for the time being. Now, for the plate, we want something shiny, kind of glossy, so I'm going to grab a Phong material, and I'm just going to middle mouse drag that into view. You can also just click it. I just have a personal thing. I like middle mouse dragging. It makes me feel good. All right. Now, the first thing I recommend you do with all materials is name them, so we're going to call this mat_plate. That way, if we ever happen to look at a listing of nodes, we know immediately this is a material. Now, this material node itself has a great number of properties or attributes that we can change to control the way it looks. Some of the more important ones that you need to be aware of right off the bat. Color, that's pretty obvious. Everybody click on the color swatch for color and just pick any color you want your plate to be. It doesn't matter to me what color you choose either. I'm going to do some sort of a palish blue plate. And let's take a look at some of these other properties. I'm not going to go over each and every one of them, just a few of the real kicker ones that I feel you should know. Transparency, that's pretty obvious. If you start to slide that left and right, you'll immediately see what that does. It makes your object transparent. If you end up wanting to make a glass, that's a good place to start. It's not the final answer. If you want to handle things like glass and reflection and refraction as well, then there's a little bit more to it, but that's where you're going to need to begin. It's going to have some transparency. Incidentally, we won't be doing any sort of reflection, refraction style stuff. Maybe a little bit of reflection, but no refraction, just to keep our render times relatively low. Ambient color is what color the darkest area is going to be. So generally, you'll want this to be black if you ever want anything in your if something isn't lit and you want it to go all the way to black, then leave your ambient color at black. If I set this to mid-gray, then the darkest my material ever gets is a mid-gray, which can be really off-putting in a darkly lit area. So it's just one of those things you can play with. Now, you can use this to your advantage, like for an eyeball or sometimes for plant life. You can kick that up very slightly, and those objects will just feel a little bit more vibrant, a little bit more alive. Okay, then incandescence. That's exactly what it says it is. It's basically the simulation that this object is emitting some form of light. Now, every time you see these color swatches, that means you can apply a color to this. So I can make this a blue object that is emitting yellowish light. And you see it starts to turn a little bit green. Just keep in mind that by default, this will not actually be emitting light. That said, you can use settings in Mental Ray such as Final Gather to simulate the effect of it actually emitting light, which is very nifty. But by default, when you click render, the incandescence will not look like the object is glowing. Bump mapping, we're going to get to. I've got a whole discussion just about bump mapping. Diffuse is going to control, it's kind of like the overall amount of coloration you're allowing. So if you crank this all the way up, your colors will tend to be blown out. If you pull it all the way down, your colors will basically go all the way to black. And so the default is around 0.8. Translucence is going to be how much color data will pass through an object, how much light data, without it really being transparent. So as you kick this up, if lights pass behind that object, that lighting information will seem to pass to the object. Think candle wax. And then you have translucence, depth, and focus to kind of help fine-tune that effect. Now, for specular shading, please understand, these 4 properties are a part of the Phong shader. So you won't see these exact same 4 properties if you were to use, say, a blend. So for instance, here we see cosine power, specular color, reflectivity, and reflected color. And these 2 are pretty constant. But if we go to blend and look under specular shading, we now have eccentricity, specular roll-off, specular color, reflectivity, and reflected color. If I grab a Lambert, we don't even get a specular shading area because Lambert doesn't use specular shading. Lambert is good for things like chalk or a really muted surface, maybe a carpet or a sheetrock wall. Okay, so what we're going to do is take our plate, and you're welcome to play with like the cosine power. The way this works is as you lower cosine power, your specular highlight gets bigger, as you can see here. As you lift cosine power, your specular highlight tightens. Now, an interesting phenomenon that I've seen with folks who are just getting into shaders is it seems like sometimes it can be really difficult to keep track of reality when sitting here just playing with sliders, because what you're doing here, you're basically taking an object, as you pull cosine power down, you're saying this would be a surface that is not particularly smooth. It would have microfacets. It would be something kind of metallic. And then as you lift it up, it becomes more plasticky, and you get a tighter sheen, something that's been waxed and is very, very shiny. So not everything is going to be clear. So hang on, let me find another way to put that. I've noticed in some students that as you sit here and play with these, you might be thinking, oh, well, I just want something to be really, really shiny, and you just slam this all the way up. I would advise you not to do that. Take your time, and if you need to, look away, look at the wall, look at the ceiling, and then come back and look at this object once again, your little your demo sphere, your sample, and see if you think it looks shiny enough or plasticky enough. And I wouldn't just immediately crank things all the way up. Go slowly. A specular color is just going to be what color that highlight is. Random thing, if you want something that is generally plasticky, it will more often than not have a white specular color. That doesn't necessarily mean that it's always going to be white. If you shine a red light at it, then the specular color will pull that red light as well. Basically, what this means is that the specular color will not influence the color of the light. It'll pick up whatever color the light happens to have. If you want to make something that's fairly metallic, metallic objects tend to pick up a little bit of their own color in their specular highlight. So you could start with blue and then start to pull that back a little bit, and you can already see where that's starting to look a little bit more like metal. So if we leave that kind of high but then pull our specular, our cosine power down, we get something that feels quite a bit more metallic. Again, that's just by knowing that objects that are metallic will tend to impart a little bit of their own color in their specular highlight due to what is called microfaceting. So I'm going to leave my cosine power at around 50-something, maybe 40-something. There's not too much of a difference between the two. And I'm going to pull my cosine power to about midway. I don't like cranking it all the way up because you end up clipping. This actually goes out to true white. And I try not to let things go out to true white where I can avoid that. Now, here's something you can make a note of. Write this down somewhere in your skull. Remember it for later. Reflectivity, by default, is always set to 0.5 on a new material. That's annoying, because that means whenever you render this object, it will be at least halfway mirrored. And we don't want this to be mirrored. I mean, if you want it to reflect a little bit of the cake, that's fine. It only needs a tiny little bit of reflectivity. If you leave this all the way at 1, it's like a perfect mirror. In fact, if you want to make mirror, or if you want to make chrome, set your color to black, set your reflectivity all the way up. And you've got a really good start. Crank your cosine power and keep your specular color very high, and you'll essentially have chrome. It's a very, very fast thing to do. So I'm going to pull my reflectivity way, way down. Now, that's it. That's all I really want to do for starters. I just need to get this applied to my plate. There's a lot of different ways to do this, but here's my favorite. I can middle mouse drag and drop that right on top of the plate. Like so. Now, did that actually apply? I don't think it did. I'd like to say I can middle mouse drag that. Wait a minute, something's not right here. Because it's getting the little plus sign and then it's not actually doing anything. That's okay, let me do it the other way. So I'll just select my plate, right click, and choose Assign Material to Selection. Alright. Here's my problem. Under Shading, I have Use Default Material on. I'm not in the wrong view. I just have a setting on. So that's one of the first things you're going to need to check. So I'll turn that off, and I've actually made my cake blue now too, because I middle mouse dragged it over there. So that's what killed that. If I want to set it back, the way I generally do this is to right click, go down to Assign Existing Material, and choose Lambert 1, and that puts it back to its default material. Incidentally, that gives you another way to apply materials as well. You can just right-click on an object, choose Assign Existing Material, and you should see the name of the material you want to assign. So if we were back to our defaults, we could just right-click, go down to Existing Material, choose Matte Plate. So there's two different ways. One is to middle mouse drag. Actually, it's three different ways. You can middle mouse drag the material right on top of the object in the view. You can select the object, hold down the right mouse button, and choose Assign Material to Selection. You can hold down the right mouse button on the object and choose Assign Existing Material and choose it from there. Still another way to do it is to go to your rendering menu set, which you can access by hitting F6, and if you go under Lighting and Shading, you will see Assign Existing Material, and you can pull it out of there as well. So there's a whole lot of different ways to assign a material to an object. So there is our plate. The only problem I have is that our plate is kind of boring. So let's make our plate a little bit more interesting, and we're going to do that with bump mapping. Now, what is bump mapping? Has anybody in here who has not heard the term bump mapping? Who heard me say that and you're just kind of like, oh, I don't know what bump mapping is. I've never heard of it before. No, look, nobody's answering. So you've all at least heard of it. Now, for those of you who have heard of it, who doesn't know what it is? Okay, cool. That's horrible, MMO. Alright, so let's jump over here and let's talk about bump mapping. I got a nice blank area of my chalkboard. And find my pen because I lose it all the time. Okay, here we are. So, let's see, bump. mapping. First off, a bump map is just a texture. Now, what did I say a texture was? Before you try to answer, a texture is just an image. But a bump map is a very special kind of image, where a bump map literally defines bumps along a surface. How does it do this? Well, I'll get to that in a minute. Let's keep it simple. Here's kind of what a bump map is going to look like. So it's just a texture or an image. So it'll be, just a picture, generally rectangular of some sort. And it's going to have light areas, maybe some gray areas. I'm not going to worry. Well, I guess I could do something kind of fancy here. I mean, I am using Photoshop after all. Let's see. Let me do this. And then I'll do this. And then I'll do a little bit of this. And let's see. Other way around. Can you go out to black for me? No, because you're not actually set to go to black. There we go. There's a really great example of a bump map, or a potential bump map. This could be a bump map. And here's where it starts to get kind of cool. The black areas of a bump map... Oh, that's awesome. Actually, let me make sure I'm on... Yeah, I need to be writing on this guy. Thank you. Ah. There. I mean it this time. Haha. Okay. The black areas are going to be recessed. They will actually push down into the surface. The white areas... And let me do it this way, because I can't point over that. That's a layer on top. So, black is recessed. White is raised. So what you're doing is you're simulating the look of the surface, in this case, in the case of this particular image, doing something kind of like this. Where this area would be black, this area would be white, and this area would also be black. But here's the catch. It's just a simulation. It just shows up at render time, because if you applied this to an actual three-dimensional plane, so let's just say we have a nice little 3D plane that didn't look horribly skewed. And we applied this bump map to it, so it was all white in the center, just like we have here. The surface would remain perfectly flat. If we looked at it from a bird's eye view, like so, and we shined a light from over here, we would actually see some shading take place around the edge of where that bump is. But if we looked at the plane edge on, it would still be a perfectly flat line. Let me demonstrate. Let's go over to Maya for just a moment. I already have a plane here. We could have a little bit of fun with this. Let's see. Let's create a temporary material. What do you say? Let's make a Fong, and I'll call this temp. You may follow along with this or not. I'm not going to be holding the class up and waiting for you, but just so you know. Now I'm going to scroll down in all of my textures, and we have a grid, we have a bulge. Oh, bulge should work really well. So would cloth, actually. Cloth should actually be pretty interesting. So let's plug a cloth in here. I'm going to plug this into the bump map and apply this to the surface. Now, I just hit 6, hopefully to allow us to see the result, but we can't unless we take a look at the high-quality renderer. Oh my gosh. It looks like real cloth. How is that happening? Because if we take a look from edge on, it's still perfectly flat. That's crazy, isn't it? And the reason being is that this is all being simulated by the rendering engine. It's a great illusion when you're looking directly at an object. As soon as you rotate edge on, the illusion is blown. By the way, for those of you out there who've been in the gaming world for a few years and you have heard the term normal mapping works exactly the same way. So when you see those game characters that look like they're just so detailed, they must be millions and billions of polys, well, that's just because of the normal map. Now, our plate, the reason it got all chunky is just because the high-quality renderer by default will simplify such objects. If I hit 3, it'll smooth it back out. So it's the computer trying to do a trade-off because it knows this is kind of an expensive renderer. So it's trying to simplify what things it can. So this is a quick example of how bump mapping works, and you can use this to your advantage to create a lot of really, really cool illusions. It's actually how we're going to create the icing for our cake, but you do get to see kind of a nice demo of it here. Something else that is also pretty neat, if we go to create lights, and let's just do a point light because they're faster and easier to play with than just about anything else, we'll hit 7, and watch this. It really does look like there's a three-dimensional surface there. But there's not. It's just the surface being perturbed by a bump map. So with that all done, let me go ahead and delete all of this stuff. I'll go ahead and reassign Lambert 1. Switch my renderer back to the default renderer. And there we go. So that is a really quick rundown of bump mapping. Now, to make our plate look a little bit cooler, here's what I'm going to do. I'm going to jump over to noise. So if I scroll down my list, you'll see a noise texture. Middle mouse drag that on top of matte plate, and assign this to bump map. And I'll go and rearrange my nodes a little bit so they make a nice straight line. Now, if I do switch back over to the high quality renderer, then you can see what this does. It creates this really hideous sort of lumpy surface. I'm going to do a few things. I'm going to take the amplitude of my noise. So if I select the noise node, I can pull down its amplitude property, and you see that keeps it from capping out. You see if you crank it all the way up, you get these flat spots. But pull your amplitude down and you get rid of those. Also, I'm going to go to Place 2D Texture, and you'll see Repeat U and V. Let's really kind of mess with these a little bit. Let's say we do, I don't know, 5 and 5. So now we've just got this kind of really generic lumpy surface. And then finally, we'll take our Bump 2D node and pull its bump depth. Just play with this slider and you'll see what it does. So as we start to pull this down towards 0, you see what happens. If you pull it to negative, you actually make little pits, little recessions. So I would set this down to something like 0.02. So there's just a really subtle lumpy bumpy to this plate. So what I want to do is pause the video, and I want to give people a chance to catch up with this. If you're actually using a polygon plate, what you'll probably need to do in order to really make this work for you is you'll have to create some UVs. So as a for instance, let me just duplicate this guy. I'm going to pull him over here. Ignore me, or, well, kind of ignore me. Let me go to Convert, and NURBS to polygons. That's fine. I really don't care what it ends up looking like. I just want the NURBS version gone. And no matter what you've got, maybe you've got something that looks good, maybe you've got something that looks terrible, but you can press F3 to go to your modeling menu set for polygons. Under Create UVs, you could probably get away with just using a best plane texture tool and clicking on like a face right in the middle of it, but let me avoid that. Let's say we do planar mapping. And I would go to the options box. So if I would go to planar mapping, open up my options, and then just project from the y-axis, that means you're projecting from directly above, and just click apply. And what that's going to do is take your UVs for the plate and just project them straight down. You will get some kind of weirdness on the far edge of your plate, but I don't think anybody would ever notice that. Like there will be a tiny trace bit of texture stretching around those edges, but again, since you're only doing lumpy bumpiness, I don't think anybody would ever see it. So again, all that would be is just go to Create UVs, Planar Mapping, open up your options, and project straight down in Y. Now, to give you kind of a heads up, just for future reference, if you open up the UV texture editor, you can now see the UV coordinates for this object. So here are all those vertices in 2D space that I was talking about, and you'll see how they fit really nicely against the texture because of that projection. Yes, there is another way to connect the material nodes. You can use the node editor, but we are not going to be using that at the moment. We'll probably get a chance to look at that before the night's out, but for now, no. Okay, so let me go ahead and pause and let people catch up. Someone had to restart Maya, and they wanted to know how to get their material back into the work area. You can clear the work area at any time by right-clicking in here and choosing Graph, Clear Graph, and it just empties it out. It doesn't delete your material in any way. Think of this as just a workbench. So that just kind of cleans up your workbench. So what you can do is show both of your tabs, right-click on a material you want to work on, and just choose Graph Network, and that'll put it right back down in there. Basically, that's pulling it out of the bin and putting it into the work area so you can play with it. Ben CG, try what Risen4 said. Go to tabs and choose revert to default tabs. So it would be under tabs, revert to default tabs. But it is a bug. I have seen it pop up, not on my machine, but on a couple other people's machines. Okay, so folks, we have been going for about an hour now. We have one material created, but we're going to go ahead and take a quick 10-minute break, and then when we come back, we will go ahead and continue creating materials for other objects. I will give you kind of a heads up. From here on out, it is going to be pretty straightforward, just building some materials. So be sure you have your thinking caps on and you're ready to follow along.